So what I want you to do to start, kind of like what we did last week, I want you to give me a multiplication problem that would give the solution 4x squared. Let's do that. So what two monomials could you multiply together to get to 4x squared? So something times something else equals 4x squared. Write it down on your whiteboard. Perfect. Not quite, Lancer. Yeah, that'll work, Otis. Not plus. There you go. Good. Perfect. 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 Okay, so what two numbers could multiply together to get to 4? Yeah, right, I could take 2 times 2 would give me 4, and then an x times an x would give me x squared. Let's do another one. What about this? 7x cubed. What two monomials could you multiply together to get to 7x cubed? I sure can. What's anything times 0, Lancer? Great. So not 5 plus 2 to get to 7, but you need two numbers to get to multiply to get to 7. You need another x. That looks good. Yes, that looks good. Your answer that you wrote down, though, is incorrect. Yes, Adriana. Yes, Otis. Not 4 plus 3. You do 4 times 3. So what two numbers multiply together to get 7? That's good. That's good. Yes. 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 Good. Please put your phone away. Yes. Good. So what two numbers multiply together to get to 7? 7 and 1. That's it. And then what two numbers add together to get to 3? 2 and 1. So I can use x squared and x to the first. And I could obviously write 1x to the first as just x, right? Does that make sense? Let's try again. So what two monomials could I multiply together to get to negative 32x to the 5th? What the cramp? Negative 32, but the rest looks good. There you go.
I need an accumulator.
Perfect.
Wait.
Not quite. 9 times 4 is 36. Do you know that trick? You need to get to 32. Did you do 8 times 4? Oh, I'm sorry. I thought it was a 9. You need to get the x to the 5th. That's going to get you the x to the 6th. Yes, but not a negative times a negative. That would give you a positive. 16 times 16 is not 32. That looks good, Adriana. Yes. Sorry, I thought it was a 5 and not an 8. Yes, that looks good. Yes, that looks good. Yes, that looks good.
Okay. What about this?
Well, that's going to get you to positive 32.
Okay,
X to the 6th.
wait.
That's x to the 6th, though. We want to get to x to the 5th. So then get you to x to the 6th. You have to do 4 and 1. Or that. That works. So what two numbers multiply together to get to 32? What two numbers multiply together to get to 32?
Well, 8 and negative.
Good, right? We got to get to negative 32. So one has to be negative and one has to be positive. And then what two numbers add together to get to 5?
1, 5, or 2.
1 and what?
4.
There. So I could use x to the first and x to the fourth, and that'll get us there. Good. How about 12x squared y cubed? Aiden, the face you make is so funny. What the heck, broski bro? And broski bro. I can't say I've ever been called broski bro before.
How many blueberries?
Not enough Y's. Not enough Y's. Oh, yes. Okay. Yep, you're good. You're good. Yep, both of us are good. Good. Perfect. Perfect. 6 times 6 is what? Perfect. Perfect. Good. Oh, wait. Yes. Yes. Uh-huh. Perfect.
I don't know how to do this.
Perfect. What two numbers multiply together to get to 12?
3 and 4.
3 and 4.
Wait, is this ready?
X and Y both of them.
Yes. And then what two numbers add together to get to x, or to get to 2? 1 and 1. So I got 1 and 1. What two numbers add together to get to 3? 1 and 2. 1 and 2. There we go. That's good. Not too bad. What two monomials can we multiply together to get to negative 48 x to the 5th y?
You sore?
Hmm?
Are you sore?
A little bit. I taught a yoga class this morning at 6 a.m.
Dang. Why?
Not 2 times 28. Good. Perfect. Not enough x's. X to the 5th. Perfect. There you go. Good. Good.
Oh, you can like take it out.
Good. Good, Soraya.
Hanging off my
Good. One too many y's. Because that's going to end up with y squared. Same with you. Too many y's. That's going to end up as y squared. Perfect. Perfect. There you go. Perfect. Okay, so what two numbers multiply together to get to negative 48? Negative 6 times 8. What two numbers add together to get to 5? 4 and 1, so I can have x to the 4th and x. And then what two numbers add together to get to 1? 1 and 0, right? So I'm going to have 1y here, 0 y's there. That's it. Cool? Okay, from here, let's just take like a little bit of notes on the whiteboard, and then we'll do the Tuesday paper, okay? So we're moving on today. So we did monomials times monomials yesterday, and now it's kind of the same thing, just like a little extra layer of complexity now. So we are going to take a monomial and multiply it by binomials and trinomials. So somebody give me a monomial. 4x, perfect. And somebody give me a trinomial. Trinomial. Huh? 3x squared. How about that? All right. What do you think we're going to do to multiply this? Show me. Distribute, right? You just distribute. So you take this 4x, and we're going to multiply it by 3x squared, and then 4x times 1, and then 4x times 2x. So what's 4x times 3x squared? 12x cubed, right? 4 times 3 is 12. X to the first times x squared is x cubed. Good. What's 4x times 1? 4x. What do I put in between these two things? Plus sign. That's good. And then what's 4x times it 2x?
Oh, x squared. 8x squared.
8x squared. 4 times 2 gives us 8. And x times x gives us x squared. Simple as that. So you're just basically doing the same thing you did yesterday, but more times. Right? That's the answer. That's it. If you give me something like your phone. You've been on it. You've been on it. It's sitting on your desk. Okay. So you should copy down this example onto your whiteboard. Take up like half the whiteboard with this because I'm going to give you another example to write down on your whiteboard. You can write small for the other one.
What the heck are you doing, Samantha?
What you doing? It's not squats. My knee is just bothering me. But it'll kind of always bothers me, so. Okay. So this is the first half of your assignment. Doing this. It's a lame collateral.
Your what? Oh, gateway.
Now we're also going to do binomials times binomials. Somebody give me a binomial. 7x minus 1.
I'm giving you the first one. 2x minus 4.
That's okay. 2x minus 4?
Yes.
Okay. Any ideas what we do for this?
Combine my.
No.
I just took a guess.
So you can multiply anything. It doesn't have to be a like term to multiply, right? I could take 3x times 4y and I get 3 times 4, 12 xy. So no.
7x times 2x, right? Would give you.
So what we got to do is we have to distribute the 7x to both of these and the negative 1 to both of these. So we're going to do 7x times 2x, then 7x times negative 4, and then do negative 1 times 2x, and negative 1 times negative 4. This is called the FOIL method. FOIL. It's called the FOIL method. Let me write it differently. FOIL. And, oh, can't spell, Mary. FOIL. Any idea why it's called the FOIL method?
Don't like foil. I'm just kidding.
Watch. We take the first term times the first term. Then we take the outer term times the outer term. Then we take the inner term times the inner term, and then we take last term times the last term. So first times first, outer times outer, inner times inner, last times last. This is like the most exciting stuff in Algebra 1. If you walk away with nothing but this and slope-intercept form, you'll be in better shape than most people going into Algebra 2. If you can remember y equals mx plus b, and if you can remember foiling, it's like some of the most important information. Because this relates, and you'll see why later, but this relates to more complex functions.
Oh.
But we don't get too far into that in this class. So let's do this. So first times first. What's 7x times 2x? 14x squared. Okay. What's my outer times my outer? 7x times negative 4. Negative 28x. What's my inner times my inner? Negative 1 times 2x. Negative 2x. And then last times last. Negative 1 times negative 4. Okay. And we're almost there. Do you see any like terms in this? Yes. So those outer terms and the inner terms are like terms. We can combine them together. What's negative 28 minus 2? Negative 30. So that's negative 30x. So that's my final answer, 14x squared minus 30x plus 4. Cool? It's not too bad, right? What do you mean?
What are you doing? I'm pretty sure he's trying to make the rags simple. And that's what it's
Are you doing both sides?
You're doing both sides. Both sides. So the front side is like this first one we did. The second side is like this second one. Get out of here. Okay. So let's take a look. Let's take a look at this together real quick. So we'll start with the side that says multiplying polynomials. You can erase it, but yeah, it's up to you. Okay, so we're gonna start with this side, multiplying polynomials. So look at number 1. What do we need to do in number 1? Distribute. So I take that 8, and do I just multiply it by x? Do I just multiply it by 5? Do I multiply it by both? Yes. So what's 8 times x, Lancer? Yeah. There you go. And somebody else tell me? Plus 40. That's it. That's all you're doing on that side, okay? Easy enough? All right. Do you want me to give you some time to work on this side and then we'll talk about the second side? Or do you want me to talk to you about the second side and then give you the rest of class to finish it up?
Talk to us about the second side now.
Okay. So flip over to the other side. And we did number 1 already. We did that one on the board. So we'll do number 2. What's the method called? FOIL. First times first. Outer times outer. Inner times inner. Last times last. Okay. So what's my first terms in number 2? 6r times 8r. And what does that give us?
48.
Yes, 48r squared. What are my outer terms here? No, those are my last terms. What are my outers? 6r times 3. What's 6r times 3? 18R. What are my inner terms? No. 5 times 8R is my inner terms, which gives me what? 40R. And then what are my last terms? Times 3. Yeah, 5 times 3, which gives us 15. And then what's that last step? Combine like terms. What are my like terms here?
48.
Yeah, 18R and 40R gives us 48R plus 15, 48R squared. Oh, I'm sorry. 58R. So we got 48R squared plus 58R plus 15. This is going to be the standard format. When you have two binomials that look like, go away, that look like this. I've got a term with a variable and a constant term. Term with a variable, constant term. When I multiply two binomials like this, I'm going to end up with a squared term, a regular variable term, and then a constant term. Okay? Those two, right? The 48R squared, that first part comes from first times first. The middle term comes from combining the outers and the inners. And then the final term comes from your last times last. Okay? So you should always, in these problems, numbers 1 through 12, you're going to have a squared term, a variable term, and a constant term. Numbers 13 through 16 are a little bit different. And I'm going to wait to teach you that until like 1:05 or something. I'll give you some time right now to work on numbers 1 through 10 on the first side and numbers 1 through 12 on this side. Okay? And then let me just tell you, in our next chapter, what we're going to be doing is we're going to be given this part, and we have to work backwards to find the factors. Super fun.
Super fun.
It is. Okay?